Distance Measuring Equipment, DME, Lock and Key. Like any other secondary radar system, DME employs an interrogation and response technique. The interrogator is fitted in the aircraft, while the responder is a ground installation. The airborne interrogator, using an omnidirectional aerial, radiates coded radio frequency pulse pairs. On receipt of the interrogation, the responder, after a fixed delay of 50 microseconds, transmits a suitably formatted reply. The only exception to this delay is where a DME is associated with an ILS. When this response is received at the aircraft, allowance is made for the delay and the time taken for the round trip is determined. Using c, the speed of light, this time is converted into distance or range and is displayed as a slant range in nautical miles. DME operates within the allocated frequency band 960 to 1215 MHz. The airborne interrogation is made on one of 126 channels at 1 MHz spacing between 1030 to 1090 MHz. For each of the interrogation channels, 2 reply frequencies are allocated. One is 63 MHz higher than the transmission, and the other 63 MHz lower. The higher replies are designated X, and the lower replies are designated Y. X channels have a 12 microsecond spacing between the pulse pairs for both interrogation and response transmissions. Y channels interrogate at 36 microsecond spacing and respond at 30 microsecond spacing. There are 256 discrete channels which have no possibility of causing mutual interference. DME identifying. DME transmits an independent identification signal in International Morse code, or a signal via an associated VHF or MLS navigation aid. The ident is transmitted at 1350 pulse pairs per second, temporarily replacing the normal reply signals. The ident is transmitted at a higher pitch, 1350 Hz, than the VOR ident at least once every 40 seconds. For a conventional DME facility, beacon saturation will occur whenever the number of aircraft interrogations exceeds 100. Search mode. In this mode, the interrogator transmits pulse pairs that are randomly jittered. Their frequency, PRF, is varied, but have an average rate of 150 pulse pairs per second. Random jittering means that the pulse pairs are not transmitted at regular intervals. As soon as a response at 150 pulse pairs per second is detected, the interrogator will lock onto the response and will enter the tracking mode. If no response is received within the time it takes to transmit 15,000 pulse pairs, the search mode reduces to 60 pulse pairs per second, and the listening gate continues to be swept over the design range of the equipment. Memory mode. A DME in tracking mode, which subsequently experiences a reduction in signal strength, will switch the equipment in the first instance to memory mode. If pulse pairs from any station are not received after a short period of time, approximately 2 seconds, the interrogator goes into memory mode, whereby distance is calculated from the most recently received pulse pairs. Memory mode expires after a short period of time, approximately 10 seconds, and the DME then re-enters search mode. Accuracy. The ICAO requirement for overall system accuracy is that it should be better than plus or minus 0.5 nautical miles, or plus or minus 3% of slant range, whichever is the greater. The design requirements for DME stipulate that at a range of 100 nautical miles, the maximum systematic error should not exceed 3 nautical miles. ICAO recommends that at distances of up to 200 nautical miles, the total system error should not be greater than plus or minus 0.25 nautical miles, plus 1.25% of the distance measured. ICAO recommendations are that range errors indicated by distance measuring equipment should not exceed plus or minus 0.25 nautical miles, plus 1.25% of the distance measured. Position ambiguity. With a DME and one radial from the aircraft, there are two possible position points on the circle from the DME where the aircraft could be. TACAN. Tactical aid to air navigation. A military TACAN can be used by civilian aviation to receive DME. Calculating slant range. A is the height of the aircraft in nautical miles, B is the actual distance across the ground, C is the DME distance displayed in the flight deck DME. Pythagoras' theorem is the sum of the square of the hypotenuse equals the sum of the squares of the other two sides. And this can be substituted into so that the height squared plus plan range squared equals the slant range squared. Calculating slant range example. A DME station is located at mean sea level. An aircraft flying at flight level 360 in ISA conditions, 15 nautical miles away from the DME station, will have a DME reading of 16 nautical miles.